the regression to actually find the resultant values. So this is how we attach our roll cage to the frame. First, we use the composite adhesive glue, let that cure for almost 5 or 6 hours, and then we use the sleeves, which is a 6K tool weaves, to wrap it around the frame, and then wrap it with strings and let it cure for almost 24 hours to get it to be the full strength. For the seat belt, we actually use a 4-point harness seat belt. We attach it on the back of the seat and also the bottom of the seat, and it fits all of our riders comfortably. And we also had during our test run, we also had a rollover, and the rider was perfectly fine. The seat belt worked perfectly fine. Also, the rollover was great.
So now about steering, based on the design simplicity and ease of manufacturing, we went on with direct steering instead of indirect and tilt steering. So the diagram on the left is a CAD model of our steering, and it shows all the components that we needed to have a perfectly working steering. And the diagram on the right shows the final product of the steering. So when we were testing our vehicle, we found out that it was really jittery and unstable. So we played around with the configuration of the stem and the handlebar. So the configuration that you see here makes it more stable than previous. Yeah. So in this slide, we see a front view and a side view of our steering assembly. So our prototype design had more steel component to it, so it was heavier and bulky. So this design is lighter because it's mostly made out of aluminum, 6061 alloy. But since the axle is exposed to the highest stress, so we decided to manufacture this axle out of steel 1045. And also, the brake mounts are made out of, we CNC'd them out of aluminum. So we needed to have aluminum something to weld it.